I'll start again then. So, basically, what you've got on the screen, you can probably see, you can probably tell, you've got the countdown to the first paper there, so under 54 days, so that's about, well, a little less than 2 months. Okay, and then what we've got is the average marks for the grades from, well, this is foundation and higher papers. So yeah, that's the average marks for the grades. That's from about the last, I think, 4 or 5 years. So that gives you an idea of what you might need to get those grades. Now underneath that, hopefully you can see, it's got the topics, or well, the topics on the test, the percentage of the questions that include those topics. So, you know, number is the most common on the foundation paper, with ratio, proportion and rates of change. So, you know, if you're looking, well, if you're doing the foundation paper and you're looking for what you should revise, if you're struggling, or if you do struggle with number related questions, or ratio, proportion and change, then definitely make sure you go and have a look at those. Algebra is the most common topic on the higher paper. Now what that means is, obviously, it's not just, you know, one question on that topic. Obviously we know they mix the topics within questions, so you know, you need to be comfortable and confident as much as you possibly can on the higher paper with algebra, and likewise on the foundation paper with number and ratio and proportion. The other things on there are recommended websites that I would suggest you have a look at. Now, one I found recently is GCSE Maths questions, which it looks very good as well. It's got lots of GCSE questions to have a look at, similar with Maths Genie. Now the grades that I've got up there, and actually where these 1 mark wonders are from, these are, you know, similar to the start of the foundation paper. These are from MathSpot, which is a good website to have a look at as well, and it's got a whole GCSE tab at the top with lots of useful resources. So yeah, I definitely recommend going and having a look at that. There is also a QR code in the corner. Buy me a coffee if you want to support the channel and support me. Yeah, okay, right, I've started going through these. The camera wasn't working, which I now know, and the sound wasn't working, but I'll go through it quickly again. 0.2 to percentage, decimals to percentages. You need to times your decimal by 100 to get it into a percentage. Okay, now the next part here, 4/8 plus 1/64, you need to, before you can add and subtract fractions, have the same denominators. So I need to change this 8. Well, I know 8 goes into 64, 8 squared is 64, so 8 times 8, and then I've got to do 4 times 8. Whatever you multiply the denominator by, or the numerator, you've got to do the same to the other one, to keep the fraction being the same value. Otherwise you'll change the value of the fraction. So 4/8 is 32/64 when you times numerator and denominator by 8. When you then add 1/64, you can now add these together. 32 add 1 is 33. The next bit I was talking about, 6 take away 9, add 9, take away 6, add 4. Okay, so you could do this left to right, and this is the order of operations. Alternatively, you can see I've got -9, add 9 here, they will cancel out and make 0, and 6, take away 6, they will cancel out and make 0, which leaves me with 4. And that's where I got up to when you couldn't hear me. Now, just let people know as well, because I can see there's more people joining. For like about the first 20 minutes, so really up until now, but I'll carry on, I'll finish. I'm planning to do, you know, these kind of 1 mark wonder questions, some basically start the foundation paper questions. The next 20 minutes I'm going to try and do, well, I will do, the end of the foundation paper and the start of the higher paper, called the crossover, if you like, questions. And then the last 20 minutes I'll be just doing, you know, the second half of the higher paper, those questions. Okay, and if you've got any questions at any point, type them in the chat. Hi Ben, hi Lucas, and hi Braden. Right, yeah, if you want to come back in about 10 minutes, because these are really straightforward, that's absolutely fine, or you can just stay on stay on the stream and watch that again, that's absolutely fine. Hopefully people that are watching, the quality's okay, and if it keeps stuttering, so well, if it does stutter at all, let me know, because then I'll change the settings for next time, or like you have done today. If anything else happens with you can't hear me or anything like that, let me know. Right, simplifying 10 to 35. Now, you simplify these in a similar way to how you'd simplify fractions. You look for the highest common factor, and then you can divide both numbers by that. If you can't find the highest common factor, you can divide both things by one number that goes into both, and then keep going until you can't divide either. You can't divide both by the same number, apart from obviously if it's 1. So I can divide both of these by 5, so that will give me 2 to 7 if I divide by 5. Now, nothing else goes into 2 and 7 apart from 1, so that's fully simplified. And if nothing else goes into the numbers apart from 1, then they're called coprime. Okay, median. The median is the middle number when we put them in order. Okay, so I need to put them in order first of all. So we've got 5, and I'll cross them off as I go. 8, 8, 12, 13, and 25. Okay, with a small amount of numbers, this is the best way to do it. So then we cross them off one at either end. So 1, 2, and you say that in your head obviously. 1, 2. Now I've got here 2 numbers in the middle, so I need to go halfway between those 2 numbers, and if you're not sure where halfway is, then you need to do 8, well, you add the 2 numbers together, 8 add 12, and then half it. Basically you work out the mean of those 2 numbers. 8 add 12 is 20, and then you half it and you get 10. So that's then our median. Okay, next question. Negative 128 divided by negative 8. Now, if you have a negative divided by a negative, the answer is going to be positive. Okay, and you can see that by, if you look at basically pattern spotting. There's a great thing on MathSpot which will demonstrate that. Again, MathSpot's a brilliant website, so go and have a look at that. If you're interested, and if you're still not convinced that a negative divided by a negative is a positive. So essentially all we need to do, we're going to get the equivalent calculation of 128 divided by 8. So I'll do that over here. I need to do bus stop method. I'm assuming I don't have a calculator. 8 doesn't go into 1, carry my 1. 8 into 12 goes once, remainder 4. 8 into 48 goes 6, so it's 16. Okay, 60% as a fraction. Now, percent means per 100. Cent being, there's 100 cents in a dollar, 100 years in a century. So that's 60 over 100. Now, we need to simplify this as much as we can. Now, both numbers end in 0, so if I divide top and bottom by 10, I'm going to get 6 over 10. And then half both of them, because they're both even. Ah, right. Thank you. Okay. That's fine. I think I've worked out a way to make sure that keeps working. Should update in a second. Ah, right, so I'm going to have to edit that in some way for next time. Let me just try and fix that now. Again, it seems like unless this is open constantly, then it's not going to keep updating. So I will try and make it so it is open constantly, and then it will carry on working. Thanks, Lucas. Okay, 6 over 10 is 3 over 5. And then the last one, 7 squared is 49, 700 squared. Well, 7 squared is 7 times 7. 700 squared is 700 times by 700. Now what I can do is I can split that up into 7 times 100 times by 7 times 100. Now because with multiplication it's commutative, I can swap around these numbers. So I can have 7 times 7 times 100 times 100. So that will give me 49 times 100 times 100. Which is going to be basically 49 with 4 zeros after it. 1, 2, 3, 4, 490,000. Okay. Next one, 6 plus x is 10, so that means 6 plus something is 10, so x is equal to 4. And then 11 over 6 as a mixed number. So you've just got to work out how many 6's go into 11. So 6, 12, so 1 whole, because that's 6 6, and then add 5, so it's 1 and 5 6. Okay, so hopefully the rest of it's working so far. Yeah, for some reason I just need to, basically the way my camera app works, I need to keep the camera kind of open. I'll look at that next time and see if I can sort out a better way of doing it. Yeah. But for now, it's working. Okay, right, so that bit's sorted. What I'm going to do now, I'm going to move on to kind of the crossover questions. So I'll leave those. Now, these questions are taken from the second half of the foundation paper, so they would be the first half of the higher paper, generally speaking. And these are from various different years. I've tried to pick different topics as well. In future, what I'm probably planning to do is look at different topics for each of these sessions. So maybe 2 topics a session, something like that, or maybe more if possible. Okay, estimate. That's the key word here. So that means we have to basically approximate each of these numbers. And I can't remember whether these questions are from calculator or non-calculator paper. So if it's possible without a calculator, I will. If not, I'll do it with the calculator. Okay. Round each of these numbers generally, as a general rule, to one significant figure. So 800. First significant figure is basically after your first number. So that's 7. You're going to look after that first number, first non-zero number I should say. If it's 5 or above, you round your first number up. If not, it stays the same and the rest go to 0. So 800 times by 300, all divided by 50. Okay, so 8 times by 3 is 24, and we've got 4 zeros. So 240,000 divided by 50. Now what we can do is basically divide top and bottom here by 10, and that will essentially cancel out one of these zeros. So we get 24,000 divided by 5. And then at this point, I'm probably going to want to use bus stop method to just work this out. So bus stop, I'll put a square root sign there, don't do that. So 24,000 divided by 5. 5 doesn't go into 2, carry the 2. 5 into 24, sorry, goes 4 times, remainder 4. 5 into 40 goes 8, and then I've got my 2 zeros, so 4,800. Okay, next question. I need to stop saying okay. One of the students the other day told me I do that all the time, so I'll try my best not to do that. Pens and pencils are sold in a shop. 12 pencils cost £1.80. Okay, just done it there again. 12 pencils cost £1.80. What I will probably want to do is work out one pencil straight away. Now this is something that I do, and by that what I mean is when I'm reading the question I work out bits as I'm going, and that makes your life a lot easier, so that when you get to the end you're not trying to work out everything all in one go. I believe generally, because the way I've done this, non-calculator, calculator, calculator kind of follows that order. So I need to do £1.80 divided by 12, and that will give me the price of one pencil. £1.80, not £12.80. I was looking at that and thinking it's wrong, and the reason I was is because I was getting basically a decimal that was carrying on forever, a recurring decimal. Now obviously that can't be the case for one pencil, because, well, unless they didn't sell pencils separately. So that's why I obviously checked it. So that means 15p is one pencil. Okay, done it again. The ratio of the cost of a pen to the cost of a pencil is 7 to 3. Work out the cost of 5 pens. Cost of a pen to cost of a pencil is 7 to 3. Now with ratios, the way I do this is with a bar modelling method, or boxes I call them. So 7 boxes for a pen, 1, 2, 3, 4, 5, 6, 7, and then 3 boxes for a pencil. So pencil, pen, make sure you label them so you know which one's which. One pencil is 15p. So split that into my 3 boxes. 5, 5, 5. We're assuming, well, we're treating these as if they're the same size. So then the same numbers go in each. So 5 goes in each of the boxes. So that means one pen is 5 times by 7, which is 35p. Then we've got to work out the cost of 5 pens. You see how actually working things out as you work through the question really helped me there to answer this question, because there's quite a few elements here in terms of how you work this out. We had to divide by 12, then we had to use a ratio, now we've got to multiply. So 35 times by 5. Doesn't say whether it wants it in pounds or pence, so we'll keep it in pence. 175p, you could put both. £1.75. Okay, the 5 pens. Okay, next question. The diagram shows a solid triangular prism. The prism is made from wood with a density of 0.8 grams per centimetre cubed. Work out the mass of this prism. Now, as soon as I saw this density written here, I thought actually I need to remember the equation for density. Okay, density is mass divided by volume. Now, a student told me this previously, and this is how they've been shown it by somebody else, and this helped them to remember it. I heart density. Now, what you then do with the heart is you can put a line through it, and you can see on the top it looks like an M and then a V on the bottom. Mass divided by volume is density. So that's just a way of remembering it, a way of remembering the equation. Obviously once you've remembered it, you've then got to know how to use it. Okay, it's just a method to remembering it, that's all. But what this is really saying as well, and if you are given, you know, a density, you can split that up and say actually 0.8 grams per 1 centimetre cubed. You can work it out from here, from the units. Okay, and also you've got this division symbol here, grams divided by centimetres cubed. Now, sometimes you won't be given that. You won't be given the density, you won't be given the units, so you can't work it out from there, and you won't be able to remember that it's written in this way. And so that's when you might need to remember something like this, which just helps you. Right, so work out the mass of this prism. So what we need to do is we need to work out the volume, and then from here times both sides by volume to cancel out the divide on the right hand side. We get volume times density is equal to mass. Okay, so done it again. We need to work out the volume. Work out the area of this triangle on the left hand side, work out the area of the cross section, then times it by the depth, if you like, of that cross section. Area of a triangle, 4 times by 6, base times height, and half it. 4 times by 6 is 24, divided by 2 is 12. I always like to write the areas inside whatever shape it is, because that is what the area represents, it's the space inside. 12 times by 10 will then give me the volume, so 12 times by 10 is 120. So that means that the volume is 120 centimetres cubed. Now the benefit of writing it out in this order here, or in this way, 0.8 grams to 1 centimetre cubed. As now all I've got to do is times both sides by 120, because I need to get 120 centimetres cubed. 0.8 times by 120 is 96 grams, and that's my answer. Now, just looking at the time, what I might do, I've got some other questions here. I've got a couple more. I can go through these, so I'll go through these questions, and then I've got some higher questions for the last kind of 20 minutes or so. If anything is not, fully explained, or anything you're confused about, type in the chat, let me know. I'm anticipating I've had fewer people watching it than initially would have done, just because I had to reset everything. I had to make a new stream. Okay, nearly on to the higher questions, but these would be on the higher paper anyway, or they were on higher papers, because these were the end of the foundation papers. Let's make a start. Let's read this question, and when we got a diagram, first thing to notice is actually there's nothing on the diagram. So what we need to do is read this question. Sorry, I'm looking backwards and forwards at the stream, making sure everything's okay. There's a few things I need to change by the looks of it, but I'll sort it out. I'll sort it out for next time. We need to read the question, and we need to put any information from the question on the diagram. So QR is 10 centimeters. So QR, that's 10 centimeters. Now, then you think, actually, do I know anything else about the shape immediately from that? So I know that if this side, it says the two rectangles, if that side's 10 centimeters, then this side has to be 10 centimeters. Well, that's only going to be useful if I'm looking at perimeters, but I might be, don't know. BC, so BC is equal to PQ, so they are the same. These will be the same as well, because opposite ends of a rectangle. The area of PQRS is 45 centimeters squared, so the area of this is 45 centimeters squared. The perimeter of ABCD is 26. Okay, so this add this add this add this is 26. 10 times by something is 45. Call that x. 10 times by x is 45, so divide both sides by 10. And we'll get x is equal to 4.5. Now we know that's the same here, so that's 4.5, that's 4.5. Find the length of AB. So we do, go back again, the perimeter is 26. 26, take away 4.5, take away 4.5. That's taking away 9 in total. So that gives me 17. And then I've got to divide that by 2 because there's two sides. So 17 divided by 2. Half of 16 is 8, so that's going to be 8.5 centimeters. And the final question that I had for kind of the crossover section is vectors a minus 2b. First thing I need to do is, I've got a and b, I need to work out 2 of b. Now that is just going to be 2 of both numbers in b, so that's going to be 6 and 4. Then for a take away 2b, I've got 4, 5, take away 6, 4, and you just take away the numbers on the top and the numbers on the bottom. 4 take away 6 is negative 2, and then I've got 5 take away 4, which is 1. So that's my answer as a column vector. Right, and that's about bang on time really. So going on to the higher questions, I've got a few questions on here. Generally with these questions, they are, because they're over halfway through the paper, they they tend to take a little bit more working out. So we'll say, got 20 minutes, and then if there's any time after that, I can perhaps find some more questions if needed. N is an integer. That means that it's a whole number, bigger than 1. Prove algebraically that n squared minus 2 minus n minus 2 all squared is always an even number. Okay, what I want to do is basically to show it's an even number, I've got to show that I can factorise 2 out of it. Now this thing here isn't in the simplest form it could be, so I want to simplify it. I want to first of all expand this bracket, and then either things cancel, or I'll be able to factorise 2 out of them. There'll be some multiple of 2. So let's start by doing n squared minus 2, leave the first bit alone, minus, and then I've got n minus 2 times by n minus 2. So that gives me, I'm subtracting, make sure to keep that subtract there, obviously don't change it, but also don't put it inside one of the brackets by mistake, because it's going to be important in a second. We get n times by n, and you can do this with a grid method if you like. So a grid method for multiplying this out would be n take away 2, n take away 2, and it's a multiplication grid, so you can fill that in. Obviously the better you get at multiplying double brackets out, the easier it will be, to the point where you can just look at them and kind of do them in your head, essentially. N times n is n squared, minus 2 times n is negative 2n, negative 2 or minus 2, negative 2 times n is negative 2n, negative 2 times negative 2 is positive 4, and then our like terms are both of these n terms here. So we get n squared minus 4n plus 4. Now this subtract is important because I've got to subtract each of these things, and this is a mistake that people will make, and so you need to make sure you don't make it. This subtract is going to affect everything. I've said it twice there. Make sure you don't forget it. You've got to leave that there until you've multiplied this out, and you've got to remember that it's subtracting everything, each term. So take away or subtract n squared. Now if I subtract negative 4n, or subtract 4n, that is going to be the same as adding positive 4n. So that's what we need to write. Okay, and the mistake people will make as well sometimes, or actually quite often, is they'll only take away the first one. So they'll take away n squared, but then they won't realise that this subtract affects this subtract 4n and this positive 4 over here. So subtract positive 4. So subtract 4. Now it should simplify to something we can factorise 2 out of. N squared take away n squared. So they're going to cancel. And then we've got 4n in terms of just our n terms, so 4n, and we've got negative 2 and negative 4, or subtract 2, subtract 4. So that gives us subtract 6, which is 2 lots of 2n minus 3. Therefore, you know, you can probably just put a square at this point, which stands for, you know, you've proven it, and that should be fine. Okay, or you could write a statement if you're unsure about what you've got to write and you want to be sure. Therefore, n squared minus 2 minus n minus 2 all squared is a multiple of 2, and hence an even number for all integers n, basically. So as long as n's an integer, this will be an integer, a whole number, and if you times it by 2 it's going to be even, for all integers of n, something like that. Okay, and that's just explaining it, but probably 99 times out of 100, just putting that square there, once you factorise out the 2 should be fine. Okay, I've done it again. I need to have a counter or something on the stream so I can keep track of how many times I do it. Right, next question. Similar kind of process. So everything that we are reading, we need to write onto the diagram. So AB is 7.3, so that's 7.3 there. CH is 8.1, so that's 8.1, that's 8.1. All of these vertical ones are 8.1. 7.3. Now this is a cuboid, so although it looks like a cube, it's not necessarily. So we don't know this depth at the moment. Depends which way you're looking at the cuboid, but from my perspective, that's the depth. We don't know that. Angle BCA. So BCA. So we've got. I'll just grab my ruler. Use a smaller one. B to C to A. So that's going from A to C here. This angle in what is a right angled triangle is 48 degrees. Now that right angle triangle is quite difficult to see, so what I'm going to do is I'm going to redraw it. Let's do a quick sketch of it. So we've got B here, we've got A at the top. I've kind of taken that right angle triangle out, and I'm just kind of this is as if I'm looking at it face down. 48 degrees here. Find the size of the angle between AH and the plane ABCD. Right, so AH, so that is from here to here. So we're looking at that right angle triangle as well. So this is the one from A to H to C that I'm drawing now. And we're triggering 3D. This is what you need to do. You need to draw the triangles out yourself, because it makes everything a lot easier to see. So that's another right angle, and we know that's 8.1, and we need to work out the angle between AH and the plane. Now the plane just means a 2D surface, so ABCD is the 2D surface at the bottom. Basically this angle here between, so that one between AH and this flat 2D rectangle at the bottom of the cuboid. So we need to work out that angle here. Now to do that, what would be very helpful is if I had another side, and then I could use trigonometry. Well, my earlier triangle that I drew, I can work out AC using trigonometry. Now I do need to put on one of these lengths. I know A to B is 7.3, and I've got an angle, so I can use SOHCAHTOA to work out AC is what I want. So that's X if you like. So opposite is opposite my angle, and then my hypotenuse is opposite the right angle, so that's the hypotenuse. So if you remember SOHCAHTOA, we need the hypotenuse to be in it, and we need the opposite to be in it, so that is sine. So sine of my angle, so sine 48 is equal to opposite 7.3 over my hypotenuse, which is X, or you can just write AC. Now I then need to rearrange this. To do that, I need to multiply up by X. So times both sides by X, and I get X sine 48 is equal to 7.3. I then need to divide by sine 48. So divide by sine 48 on both sides. And I get X is equal to 7.3 over sine 48. And that will give me an answer for X. Now, what I don't want to do here is round this number, because it's not my final answer. Also, when you're doing trigonometry, make sure you've got the D at the top of your calculator for degrees. If it's in radians, you'll get a different, so it says R at the top, you'll get a very different answer, and everything will go wrong. So make sure you don't do that. So it gives me this answer, 9.823118926. So that is AC, and I've written down all the numbers so that I don't get a rounding error. I can't get the exact value There's no exact number, there's no surd, there's no amount of pi, which is basically what exact form is usually. Right, so I've written down all the digits so I can't go wrong. I now need to work out this angle, so I'll just separate my working off here to keep it nice and neat. Now with this angle, I've got opposite. My hypotenuse would be this one, opposite my right angle, so this is adjacent. So opposite and adjacent is tan, and I can call this angle alpha. So tan of alpha is equal to 8.1, my opposite, over my adjacent. So over this answer that I just got, which is still stored in my calculator, so that's good. 823,118,926. Okay. Now I need to do, because I want to work out the angle alpha. So how do I do that? Well, tan of alpha is this, tan of my angle is this. So I basically need to undo this tan function, and the way to do that is by doing inverse tan minus 1. So I need to basically tan minus 1 both sides, inverse tan both sides. Now that just makes this tan disappear, so I get alpha is equal to tan minus 1 of 8.1 over that number, which I've just still got on my calculator as the answer button. So now I'm just going to type in, so you have to press shift and then it's just above tan in yellow or orange on my calculator, fraction button, 8.1 over answer, because that was the last thing I worked out, so that's fine, equals, I get 39.5, and the question wants it to 1 decimal place, so 39.5 is my answer. Degrees, 1 decimal place. So with that, you've got to take your time about it. You've got to work through it part by part, bit by bit. You've got to think about what you do know, what you don't know. You've got to remember that actually with these types of questions, there are going to be right angles, there is going to be trigonometry in there, and there could be Pythagoras, depending on if they give you a side and a side. So if I didn't have the angle here, if instead they gave me BC, then I could use Pythagoras to work out AC. So yeah, it's going to be either trigonometry or Pythagoras. Next questions. Simplifying. So, what we need to do for this question is basically to factorise everything. Factorise everything, and then there should be some brackets that will cancel. The whole point of this question is that things cancel. So I'm looking at it, and actually the easiest thing to factorise first of all is the denominator. So I'll start off with that, and you'll see actually when I've done this why I've done that. So I'll leave, well, I won't write anything for the top just yet. Okay, now I can factorise out 2, and both of these terms also have x in them. Now because it's got a squared here, what most people think is that it's going to factorise into 2 brackets. Well actually, if you don't have an integer at the end, if you don't have a number term at the end, then actually you're not going to end up with 2 brackets, because both of these other terms are going to have x in. And this one, if I factorise the x out of that, subtract 6x, then that will just be 6 by itself. So 2x outside. Now what do I times 2x by to get 2x squared? Well, that's x. What do I times 2x by to get 6x? Well, that's 3. So we get this. Now bear in mind that the whole point of this question is that things will cancel either on the top, or, well, they will cancel top and bottom. So I need to factorise this quadratic at the top, and it's got all 3 terms, so we're going to have 2 brackets. Now because I've got a bracket on the bottom which is x minus 3, I'm expecting, it's very likely that on the top I'm going to have a bracket that's x minus 3. So I'm going to work on that presumption so that things cancel. So x minus 3 is one of my brackets at the top. 99 times out of 100 that will be the case, because that's the whole point of this question. Now, I've already put x here. I should have put 3x, because 3x times x is 3x squared. Now, what does that give me? 3x times by x is 3x squared. 3x times by negative 3 is negative 9x. Okay. Negative 9x, I need to get to negative 8x. That's an x there, so I need to add 1. 1 times x is 1x, so I've got 3x times negative 3 is negative 9x. 1 times x is 1x. Negative 9 add 1 is negative 8. So that does work. Also, 1 times negative 3 is negative 3. And then, exactly like we thought it would, x minus 3 on the top will cancel with x minus 3 on the bottom, and we get 3x plus 1 over 2x, and that's the final answer, because we can't simplify that anymore. There's nothing that will cancel. And one thing to clarify with, or one thing to say with questions like this, is people want to cancel, people try to cancel things that have been added on the top and on the bottom. You can't do that. You can only cancel things when they've been timesed. In the same way that, for instance, you know, you can split, let's say, 6 over 10 that we had earlier. 6 over 10 is 2 times 3 over 2 times 5. Now there's 2 on the top and the bottom, so divide top and bottom by 2. That's basically cancelling the 2's out, so that's when you get 3 over 5 like earlier. Okay, that's a little aside, and that's doing it with numbers. That's what we're doing just with algebra, but it has to be multiplied by everything. Okay, you can't just look at the x squareds and go, well, that's 3 times x squared, so I'll just cross that out, I'll cancel that out with 2 times x squared. You can't do that. It has to be multiplied by everything. In the same way that I couldn't have gone 1 plus 1 times 5 is 6 over 2 times 5 and cancelled the 5's out and got 2 over 2, which is 1. 1 plus 1 over 2. That's not right. Don't do that. Okay, so only if it's multiplied by everything. Okay, next question. The graph of the curve C with equation y equals f of x is transformed to give the graph of the curve S with this equation. Now these are transformations. These are relatively straightforward as long as you have learnt the transformations. Okay, so transformations are something you are just going to have to learn what they do and practice them, and what I'd recommend if you're not sure is using GeoGebra. It's a great tool to go on to type in a graph, and what I would do, probably, well, one of the best graphs is y equals x squared, because you can look at the minimum point, and actually they have quite a few questions like this on Maths Genie where they have past paper questions looking at the minimum or the maximum points and where they move to under certain transformations. So you can try that yourself on GeoGebra, and obviously the more you practice it, the easier they get. The other thing is, of course, well, just practicing these as much as you can, really, in order to learn how to do them. So practice exam questions. The other graph which would be useful is a cubic graph. So if you were to put into GeoGebra something like x minus 3, x plus 2, x minus 1, something like that. Now that would have solutions at 3, negative 2 and 1. That's what would cross the axes, the x-axis. Now that gives you some key points to look at when you're doing these transformations. And what I would type in is then, so I would have f of x is equal to this, and then underneath what I would type in is, you know, f of x plus 3, f of x minus 2, things like that, and see what happens to the graph. Okay, that's not my working out, that's just a little aside for you to go and have a look at on GeoGebra and to practice there. If you're not sure with transformations, investigate them yourselves. That's the best way to learn maths. The last thing then, the last question I'll do, because I said I'll finish at 11:30, so I will. And then we'll do these sessions again next week as well, and if there's anything people want me to do, put it in the chat, and I can do it. And if there's anything I need to improve as well, if you know, if I teach you at my school, you can tell me in school. Otherwise, you know, type it in the chat and let me know. Okay, so we start reading this question. The graph of the curve C with equation y equals f of x. This is how they like to lay it out with transformations, which is why you put f of x here, is transformed to give the graph of the curve S with this equation. Point C with coordinates 7, 2 is mapped to the point Q on S, where S is this curve up here. Find the coordinates of Q. before it even got to this point, what I would probably have done is worked out what this does. Now f of negative x, that changes all your x coordinates, so say it's like at positive 2 to negative x, so we go from positive 2 to negative 2. Okay, so basically that's going to flip all of your all of your points, all of your coordinates across your y-axis. So reflection in y-axis, and then the next one, f of x minus 3, that's going to be a translation, and because it's outside the bracket, it's going to work the way you'd expect it to. It's going to take away 3. Remember, this is y equals f of x. Take away 3 from my y value. So my graph is going to move down 3. So translation 3 down. Okay. Find the coordinates of q. So we need to reflect in the y-axis. So if we do a quick sketch just to help us, let's say that's 7 here, let's say that's 2, our points here. Reflection in the y-axis, going to bring it over here, so we're going to have minus 7, 2, and then minus 3 is going to translate that 3 down, so down to 1, 0, minus 1, it's going to be down here. So the coordinate of q, q is equal to minus 7 or negative 7, negative 1. Okay, now I'm going to finish in a second. Before I go, you know, if you haven't already, if you can like the video, I'd very much appreciate that. It lets me know actually that the video was useful and this was worthwhile and helpful, and you can go back and re-watch any parts you need to. You can comment in the chat if anything was not explained, you know, or you didn't understand it, and I can go through that maybe next time, or you know, I can even go through it now. That's absolutely fine. Just let me know, and of course, you know, I'm going to be doing these I'm going to say at the moment every Sunday 10:30, same time, and I'll set it up better next time so it works. Yeah, works better. So subscribe so that you can keep up to date with that as well if you haven't already. Can't get my words out, and yeah, I'll see you in the next one, and hopefully it goes better. See you next time. Bye bye.